Okay, let's consider this equation. 3x minus 2y equals 7. All right, now let's see if we cannot represent this represent y here as a function of x. So let me rewrite this down here. 3x minus 2y equals 7. So what am I going to do? Well, I want to isolate y on one side of this equation. So I have to add 2y over here. And that eliminates that. Then I'm going to divide this 7 over here. I'm going to try to isolate y, so I want to get rid of the 7. So I'll subtract 7 there, add 7 over here. Okay, now I still have 2y over here. So in order to completely isolate it, let's divide this by 2, which means I have to divide this side by 2. So we end up now with y equals 3x over 2 minus 7 over 2. This actually, if I subtracted 7 over here, I should have subtracted 7 over here, not add. So now I've written this so it's in a really clear form that shows y as a function of x. And I might start asking some questions about this now. I might ask, do these points satisfy the equation? Maybe I'll ask it about this point where x is 1, y is minus 2. Maybe I'll ask it about this point where x is minus 2, y is 1, and perhaps this point. X is minus 1, y is minus 5. So how might I determine if those points satisfy the equation above up here? Well, the simple way is to put these points in the equation, and if they satisfy it, the left side has to equal the right side. So for the first one, we get 3 halves times 1, because I'm putting 1 in for x, minus 7 halves equals, and if this is correct, it should equal minus 2. So for 1 minus 2. So I've got 3 halves minus 7 halves. It's going to be minus 4 halves, which equals minus 2. And that's correct. Minus 4 halves does equal minus 2. So we could say yes. Yes, it does. Okay, let's check out the next one. Putting minus 2 in for x, we have 3 halves times minus 2 minus 7 halves equals, and this equation is saying 1. So this is minus 3 minus 7 halves equals 1. Minus 3 is the same thing as minus 6 halves. I want the numerator and denominator minus 7 halves. That's going to equal minus 13 halves. That does not equal 1. So no, this point pair does not satisfy this equation. Okay, let's just do one more here, the last one. Minus 1, minus 5. So we've got 3 halves times minus 1 minus 7 halves equals minus 5. Well, minus 1 times minus 3 halves is going to be minus 3 halves minus 7 halves. That's going to equal minus 10 halves, which does equal minus 5. So yes, this one does satisfy the equation. These points do satisfy the equation. So I've redrawn the points and that equation down here, and I stuck in here a Cartesian axis system. And let's take and plot these points on this. So for example, 1 minus 2 is this point right here. This is the point 1 minus 2. 1 in the x direction, minus 2 in the y direction. Let's do minus 1, minus 5. Is this point here. Minus 1, minus 5. So these 2 points satisfy this equation. Let's find another point that satisfies the equation. Suppose that x equals 2. If x equals 2, what does y have to be? So if x equals 2, we're going to look at 3 times 2 over 2 minus 7 halves equals, so that's 6 halves minus 7 halves equals minus 1 half. So if x equals 2, then y equals minus 1 half. That's here. Now notice, all these points let's do it in a different color. Fall on this line here. All the points that satisfy that equation end up falling on this line here, this blue line. So if I were to choose 3, we would end up somewhere around here, somewhere around 1 should be the answer. So let's try that. If x equals 3, then we have 3 times 3 over 2 minus 7 halves. So we got 9 halves minus 7 halves equals 2 halves equals 1. So it does actually equal 1. So we could stick that in there too. All those points end up on the line, and notice that this point here, when minus 2, 1 is way over here. It doesn't fall on this line. So it does not satisfy this equation. It does not fall on this line. So this is actually an equation for a line. And put these points in red here so they show up a little more. And actually, if I would have drawn this correctly, well, this is an equation for a line. So it's the scales are a little off. But that looks like that. Okay, notice that if x equals 0, what would we expect y to be? Well, if x equals 0, this term's going to drop out completely. This term here will drop out completely. So y is going to be minus 7/2, which is minus 3 1/2. That's this point right here. You can see that I have my plot, my scale drawn poorly. So let's just let's see if we can't fix that. Let's go back here. It's going to be hard to fix, actually. But I'm not going to be able to accurately do that. But I would say that 4 should be here, and 5 down here, and 3 maybe here, so that I can cross this y-axis at 3.5. So when x equals 0, that's where you cross the y-axis, or you can say that's the y-intercept. So this is the y-intercept. Y equals minus 3 1/2. So we can have other types of lines. We could have a line that is, say, just a horizontal line. So suppose this is the value of 2 here, and I draw a line that's horizontal. I want to do it a different color, though. Line that's horizontal. That means it's parallel to the x-axis. So here's our x-axis. Here's our y-axis. So what is an equation for this line? Well, every point on this line has to be satisfied in the equation. So if we think about this, no matter what x is, if x is 0, y is 2. If x is 1, y is 3. If x is 3, y is still 3. So no matter what value we have for x, let's even go minus 1. Minus 1, y is still 2. Actually, these are all 2's here, not 3. So y is always 2, doesn't matter what x is. So how do we represent that? Represent that by writing y equals 3. That's the equation for a horizontal line. Y equals some constant value. And not 3. I don't know why I got 3 in my head, but y equals 2. It's constant value. So that's a horizontal line. You could also have a vertical line, like this. But this vertical line is not y as a function of x. So when you have a vertical line here, it's not a function, or y is not a function of x here, because for some value x, suppose this is 1, this is 2, this is 3, for a value of 2, when x equals 2, y can equal an infinite number of different values. We might say here that x equals 3. But again, in this, y not a function of x for this. All right, that's all for this chapter.